this tutorial, I will show you how to make a 2D platformer using the Unity game engine. First, you're going to want to delete the main camera that comes in with every scene by default. Keep the directional light, we don't want things to get too dark. Press this 2D button up here to go into the 2D view since this is a 2D platformer. And then right click in the hierarchy, press create empty to create a new empty game object. And where do we want this game object? Where we want its position X to be 0, Y 0, Z 0. Set all of its positions to 0, or you can just do it by pressing the 3 dots next to the transform component, which is what manages position, rotation, and scale values for the object. You press the 3 dots and press reset, and that'll do that too. But it'll set all of the values to 0, and then set the scales to 1, which works. So now we have an empty game object right there at the world origin, which is 0, 0, 0. Next, we're going to need a sprite. So we could add a sprite renderer to the main object, but instead what I'm going to do is I'm going to add a new empty game object by right-clicking on the main original game object, and it will parent it to it. Which means if we move the one higher in the hierarchy, it'll also move the one lower in the hierarchy relative to the parent, which is this one. I'm going to rename the parent to player to get a better idea of what we're doing here, and rename the child to sprite. We will then add a component to sprite, which will be sprite renderer, and then press the dot next to the sprite to actually give it a sprite. I will just use the Unity default knob, but you can assign any sprite you want and set the values accordingly, such as the scale. So I'm just going to scale it up here. That looks about right. Go to the main player object and add a camera. This is going to be how we actually can see the game, because if the player can't see the game, then the player won't be able to play. And you can immediately see a problem. You can't see anything in the viewport. This is the viewport. This shows how the game looks out of like the main camera. You can't see anything because the camera is overlapping with the player, which isn't what we want. So just take the Z coordinate in the transform component on the camera and set it into the negatives to move it backwards until it looks about right. That looks good. Negative 7.21 for me. You can do some things differently. If you're using a different sprite, it would make more sense. So now we go back into 2D view with this little button here, if you haven't already done that, and now we can see our player, and everything looks accordingly. Everything looks right. Everything looks fine, but we can't move our player yet at all. If we actually try and play the game, we'll just have a still picture of a knob. So let's fix that. Let's do a Control S to make sure we save our progress. Click on the player and add a player movement script. We're going to open this up in Visual Studio. Download for that will be in the description. So then we press create and add, and it will create a script and automatically open up in Visual Studio. We have our script, player movement, opened up in Visual Studio. So we're going to delete the start function as we do not need this, and now we are left with our update function. Anything we put inside the update function will be called every single frame. So every single frame of the game, what we want to do is call an if statement, like this. And inside of this if statement, we need to check if input.getKey is, let's say, D for now. We're using like WAS and D for a 2D platform. You can use whatever controls you want, but for me, I'm going to have D move our character to the right. So what this if statement does is every frame, it will check if input.getKey D, which means if you're pressing the D key as input on your keyboard. This is how we check for input in Unity, or at least it's one way to do it. I think it's a decent way, because even if you want to add custom keybind functionality, you can replace this with a variable and assign that variable with a string, and then you can customize what the keybinds are, or have the player be able to customize them in the game itself, which is something I've done for other games that I make, like Battle of the Bobs and such. So now we have to make the player move if the player touches the D key. If the player taps the D key, then we need the player to start moving, specifically to the right. You press D, you move to the right, you press A, you move to the left. So let's quickly select all of this by holding down left click, and then enter, Control V, and replace this with an A. And so now we have two functions, one for D, one for A. Whatever we put in here will happen when we press A. Whatever we put in here will happen when we press D. Simple. And so now we need to make the player move. How do we make the player actually move? Well, we can use a reference, public game object, press tab, it'll autocomplete, and then player, and then you end it with a semicolon because this is a reference, or a definition. So in the inspector, you can actually take something that you've defined. So like any reference to player in this. So if I type in like player dot set active, and then I put in a value in between these parentheses, false, this will turn player off. But what is player? Well, it's defined as a game object up here, and we will later insert what the player actually is in Unity in the inspector. So I'll get to that in a second. So let's just go with this reference here, public game object player. If you press D, we want to take player and find the transform component from within that player by doing .transform. It's a nice little Unity feature. And what value of the transform do we want to change? What like stat of the transform component do we want to change? We want to change its position. And specifically, we want to change its position .x. We want to change its x value to something greater than itself. So we want to set it to itself plus like a value, say 1. And then it would end that with a semicolon. Now this would normally work. Unfortunately, this value cannot be assigned to. We want to add a number to x by making x equal to x plus 1, but that doesn't work because this value is unassignable. It's read-only. How do we fix this? It's a little complicated. You have to make the position itself, you have to assign that to its own thing. So you have to make it equal to a new vector3 being a grouping of like 3 different values. And then this is a method, so we put in some parentheses, and then we put in some basic numbers. And then we end it with a semicolon. And this will work. This will set our position to a new vector3 because positions are stored as a vector3. You can see it says that right there. Transform.position gets set, it's a vector3. The world space position of the transform is basically, well, your position, your coordinates. And we need to set its coordinates in the vector3 format. So we can set it to, say, 5, 0, 0. And it will set its x position. It will set its x position to 5, its y position to 0, and its z position to 0. The problem is, we want to add values. We want to add a value to the x. So what we will do instead is swap out the x, not set it to a specific number, but set it to the current x value. And then we will do that for the rest. Player.transform.position.y. And I'll show you what this does in a second. Player.transform.position.z. So we're setting player.transform.position equal to a new vector3, which is player.transform.position.x, the x coordinate, the y coordinate, and then the z coordinate. This will set all of the positional coordinates equal to themselves. This will not change anything. If your x is 5, then when you press D, your x will be set to 5, and it won't change. It'll be the same as before. So how do we make it actually change? We can just add it like a plus and then some value. So I'm just going to put in value as a placeholder. So now when you press D, your x will be set to your current x plus a certain value. If your x is 5 and you press D, it'll be set to 5 plus value. And then if you press it again, it'll be set to 5 plus value again. It'll continuously add on for every frame you're pressing D, as this is indeed in an update function. Update is called every frame if the mono behavior is enabled, which it is. Don't ask what mono behavior is, that's just a Unity thing. But what is this value? Well, this is an error, which is giving us an error because the name value does not exist in the current context. We need to define value. So I'm going to change this to move speed, or actually move value. There's still an error. We haven't defined move value, so let's define it. We will define it as a public float, move value. Floats are basically just numbers. They can be decimals or integers, negative, positive, all the way up to very, very high values. So we can just set move value to be a float, and so now the error goes away. And we can later assign this value an actual, value in the inspector. I'll get to that in a second. So now, but how do we make him move in the opposite direction? Well, we can copy the code we just used, and then change this to a minus sign. So now we can subtract the movement value from x, making the character go backwards instead of forwards, like doing the opposite. Or we could have plus and then the negative the opposite of the move value. Even if the move value is minus, then it will do minus minus and turn positive, but that's not necessary. This is more simpler to understand and also kind of simpler to write. So we'll just do this. Minus move value if you're going to the left, plus move value if you're going to the right, because going to the right is always the default for some reason. And so now we've set up the basic movement. If I Control S this, if I save this and go back into Unity, you can see that none of the values are really a value. Move value is 0, which is not going to work. It's going to add 0 to the x or subtract 0 to the x. The player isn't going to move. That's not going to work. So I'm going to change this to say 0.1 and but in the code it's changing the x position coordinate of player. But player isn't set to anything right now, so that'll throw an error. So we need to drag in the player itself, this guy. This guy right here. Let me go back into 2D mode. This guy right here, we need to drag in this object. How do we drag that in? Well, not like that. We need to reach down into the hierarchy, this is a hierarchy, and hold down the left click on the player, drag him into the component, into the player movement script that we created. Well, I created, you created, whatever. So now player is defined as the player itself, so if we try and in the code change this x coordinate value in the transform component, then it will change this player's x component, moving the player itself. If we try and run this now, we should be done, but we're not for two reasons. For one thing, there's no background at all. The movement does work, but we're not falling, there's no physics. In most platforms there are physics. I'll show you how to add that in a second, but also, you can't jump. And every platformer needs jumping, right? But how do we do that? How do we add physics and how do we make stuff jump? It's actually extremely simple, at least the physics part is. Jumping's a little more involved, you need collisions and stuff, and I'll get to that in a second. But in order to make things fall, you just add a component. You don't have to write your own physics engine. Unity does this for you, and then you choose Rigid Body or Rigid Body 2D. This is a 2D platformer, so we're going to go with 2D. So now we just have to body type dynamic. That's what we want. That just means it's affected by physics. Kinematic means it's not affected by physics, but it can detect collisions from physics objects and also from other kinematic objects, I believe. Collision detection. Discrete is a much simpler and faster version. Continuous means that if you're going really fast, you're not going to phase through walls. But that's not really necessary here because assuming this move value can't be changed in-game, no one's going to be able to go fast enough to phase through a wall. Unless that's what you want, then you'd set this to continuous. But it might run a little slower, maybe, sometimes. So I'm going to keep this at discrete for now. Gravity scale 1, that's what actually makes us affected by gravity. Mass, don't worry about that. That's actually irrelevant here because we just want it to fall in general. And we're not using forces for movement. Interpolate doesn't matter. And so now we're just set up. We're just set up. That's all you had to do is add the Rigid Body 2D component. So now if we try and run it, everything's going to be fine. Except we don't have a ground, so we're just going to fall into the void forever. So how do we add a ground? Well, you can create a new empty game object. Do not parent it to the player. And so now all we have to do is make this an actual ground object. So I'm just going to press the three dots next to the transform component and press reset. Or you could manually set each of the position coordinates to 0. That works too. And now, oh boy, so many steps. We make sure the game object is in the same position as the player, and then we give it, once again, a sprite renderer. Drag in a sprite for a sprite renderer. I'm just going to use default Unity background because it really doesn't matter right now. You know, enlarge it, stretch it out, and then move it down a bit. And now we have a ground, and everything should be fine. Except there's still one problem that you're about to see. You fall for the ground. You fall for the ground, and that's not because the Rigid Body 2D collision detection is set to discrete. Continuous only affects stuff going at high speeds and stops them from phasing through walls. So if you're not going at high speed, discrete should work pretty much perfectly. So what's the problem? We don't have any colliders. Everything in 2D or 3D physics in Unity and most game engines pass through each other if they don't have any colliders. If there's not, like, any system that is put in to stop them from going through each other, everything phases through other objects by default. So how do we stop that from happening? Well, it's another Unity component. You just type in box collider, or just collider. It depends on what object you want to do. If you want a circle collider, you can press one of these, but box collider 2D is what we want because this is 2D. Box collider for 3D, which would be the other one without 2D, that's not going to work here. So let us go box collider 2D, and so now we have a nice box. And then we can adjust all of these values like this X size, or the Y size, or a better way to do it would just be to hold down left click on these bits and move them around. There we go, that looks pretty good. Yeah, just make that nice and fit your sprite. Obviously I chose not the best sprite for this because it's blurry and weird and not a perfect square. You might have better sprites, either that or you can just make your own and like paint or something, I don't know. You set up the collider, and no need to add a rigid body or anything to this. That'll work fine. And now everything will be fine, or at least it would be if we added a collider to our player, which we didn't. So let's add a collider to our player. Our player is a circle, at least this player is a circle, yours might not be, then you can add the box collider 2D. Or if it's a custom sprite, you could have Unity do it for you by using the polygon collider 2D, which brings it around. It doesn't really work well on this sprite, but normally it works pretty well and puts a collider around your sprite itself pretty well. But for this, we don't need anything fancy. We can just use the standard circle collider because my character is a circle. Your character might not be a circle. Use something different. But now our player has a rigid body 2D and a circle collider 2D, and it has the basic movement setup. You can go to the left and to the right, and it falls. And now it has a collider, so it collides with the ground, which also has a collider. And yada yada, collider, collider, collider. And now it should work, and it does. And if we walk off of the ground, oh well, that's one other problem. This thing can still rotate. Actually, I can fix that real quick. I know how to fix that. You just go to Constraints in Rigid Body 2D. This also exists for 3D rigid bodies, but we're using 2D. And then you just freeze rotation. Set that. You can also freeze position Y if you don't want it to be able to go up and down. That's always an option, so we're going to freeze rotation. And it should work. And also I'm going to bring down the move value a little bit. 0.02 should work. Now we can move left and right, and we no longer fall. Well, we do fall, but we don't rotate. That should work pretty well. So how do we add jumping? That's actually kind of simple, sort of. First of all, we need a way to detect that we're on the ground. You don't want to be able to jump if you're not touching the ground. Unless you want that, then you can just cut off that part, but I'll get to that later. So, assuming you can only jump when you're on the ground, you have to be touching the ground to jump. How do we detect if you're touching the ground? Well, there is a way to do it. You can check if you are touching the ground by making a new box collider 2D on your character, and then customizing the scale so that it fits right underneath you. And now, immediately, this would cause a problem. Oh, well, now you have some weird, funky collider underneath you, and the collisions are going to be weird. We can set this new box to isTrigger so that that doesn't happen, and then maybe set it down here or whatever. So now, the fact that this box is a trigger will make it so, if we play the game, it affects nothing. It intersects with the box. As you can see, it's intersecting. This box is intersecting with the bigger platform. But doesn't that mean it's completely useless? Doesn't that mean it's basically not there? It's not even there at all? Well, no. It is still there, and the game recognizes when there's intersections. We can keep track of this in code. And so what we can do is make it so if you're pressing space and this box is intersecting with the ground, which means if you're pressing space and you're on the ground, then we jump by adding a force using the physics component. So let's do that. But how do we do that? Kind of simple. We don't actually need to reference the collider itself. Unity can do that automatically. We just have to make a new function. Void update calls stuff every single frame. Now we need a new function that calls stuff every frame only if our trigger box that's underneath the player is intersecting with the ground. How do we do that? Well, this specific function is called onTriggerStay 2D. We want to use the 2D version. If there's no 2D in the title, then it's 3D for some reason. Why isn't it on trigger stay 3D and on trigger stay 2D? I don't know. The default is 3D. So let's just go for 2D. Collider 2D collision. You don't have to worry about that. Collision is just what we're colliding with. So we can just make a nice if statement to check to make sure that the collision, the thing we're colliding with, is in fact the ground and isn't something that we don't want to affect us. This is necessary, by the way. Then collision.gameObject.tag, we can check if the game object that we are colliding with, that we're intersecting with, has the game object tag of ground. We use two equal signs when comparing tags. If this object's tag is equal to ground, if it is ground, then we can, well, jump. If we're intersecting with the ground, then we can jump. But how do we make it jump? Well, we can take player and then get a component. This is a neat little thing you can do. Get component rigid body 2D, and then you put it into parentheses because it's a method and stuff. Player.get component rigid body 2D dot add force. This is a neat little void, a neat little function you can call for the rigid body 2D component. It's just a neat little thing you can do. Add force. How does add force work? It's pretty simple. You just do 0, 0, 0. It uses vector 3s, so then we can add force and make it get pushed in a specific direction, either x, y, or z, positive or negative for any of the values. So we're going to do y because y is up and down in Unity. So we can set this to 0.5. And then that gives us an error because 0.5, it thinks it's an integer because the rest are integers. But it's not an integer. Of course, 0.5 is not an integer. It is a decimal. And so we need to make it a float because only float values can be decimals. And also doubles, but those don't count. So how do we fix this? How do we convert it to a float? We can just press F. And then Unity is just like, oh, okay, 0.5F. So it's a float. Okay, that makes sense. So add force, and then add a little force upwards. Oh, wait. Okay, actually I made a mistake. This is the way to do it in 3D. But we're doing it in 2D, so we have to use a vector to force. So I'm just going to write the word force. It gives us an error. Force does not exist because we haven't assigned it. I will assign it in a moment. So let's go up here and let's assign it. Public vector to force. Assigning force to a vector 2. Since it's 2D, there's only two values we need to change, x and y. You can't change z in a 2D game because then you'd go into the third dimension, and that breaks what 2D games are, so you can't do that. So now we just have to set what force is equal to in Unity. So let's assign it and test it. We go to the script, force, set this to, say, 0.5. We don't have to put an F in this case, since we're just assigning things in the inspector, which is this place, this whole place. So now force.y is equal to 0.5. So now we should go 0.5 upwards if, and only if, we are touching the ground. Which means if I start the game, we shouldn't start going up immediately. We should only go up once we touch the ground. And we do not. Is the force too low? Oh, okay. Actually, there is another problem. This would work if we gave the ground a tag. So let's give the ground a tag. This object right here. Let's give it a nice tag. And let's add a tag. Call it ground. Save. And assign. By pressing here and here. So now, the ground, the thing we want to treat as ground, has a ground tag. Which means it should be recognized by our script. It should be. So let's try it out. We got this all set up, that all set up, this, that, and this, all of that. Then we press play, and increase the force. And now we're stuck bouncing. We go up, but then we fall back down, and then we touch the ground and we get sent back up. And now we're just a bouncing ball. I'm not touching anything. I'm not touching the spacebar because there's nothing that checks if the spacebar is being pressed. This is still not really a platformer. You want to press space to jump, and if you're not pressing space, then you shouldn't jump. You shouldn't be constantly jumping. That doesn't work, but at least it shows that the main code works. It's just jumping all the time. So let's quickly make it so this only happens if you're holding down space, or if you're just touching space. Let's do that. So if you're touching the ground, then jump. That's not what we want. We want it to also check if you're pressing the spacebar and not work if you're not. So let's just do exactly what we did up here, and we make an if statement. What do we put in this if statement? Input.getKey. Yes, the spacebar is counted as a key. But we can't do quotation marks and put in spacebar. That doesn't work. And it kind of makes sense why, because this just checks if the string is equal to the letter. Like if it's D or if it's A. And here, spacebar, there is no letter that means spacebar. So that doesn't work. We have to use a different way of categorizing the keys. Instead of putting the name of the key in quotation marks, we get a key code. So we type in keycode.spacebar, or just space. Keycode.space equals 32. That's just a weird numerical thing. So now we only check if the key that is being pressed, if the key with keycode space is being pressed under input, then and only then should you jump. So if you're pressing space on your keyboard, then jump. And if you're not pressing space on your keyboard, then don't jump. Don't add force. That brings you upwards, which is a jump. So now we can press space to jump, and we can move left and right. That's pretty platformy. That's pretty platformy. So let's test it. We have everything set up. We have the values nice and good. At least they seem pretty good to me. And there we go. It works. This is some pretty solid movement here. We're not phasing through any objects. We can jump around. It feels pretty smooth. And if you don't want to use the spacebar, you can go back into the script and swap out keycode.space to whatever you want. So like W, and then you press W and you space. Well, you press W and you jump. That works too. Or you can always mix it up. You can duplicate this, make two if statements, and then put a W here. So now if you're pressing spacebar, you'll jump, and if you're pressing W, you jump. So they both work. That's another possibility. But let's just go with the space for now. I mean, I'm going to go with the space for now. You can do whatever you want, of course, but now you can move left and right, and you can jump. So what exactly are we missing? Pretty much nothing. That's 2D platformers. And that is how you make a 2D platformer in Unity. With, like a couple dozen minutes of tutorial watching, I guess. It works. And of course, if you want, you can mix whatever you want up. Change the camera. You move it over here, and everything will still work properly. You can move it back, you can move it out, in. You can rotate it into the third dimension if you really want to. It would look kind of weird, but hey, maybe that's just a camera angle you want. It works. It's possible. Set this to orthographic, and things will get wonky in a hurry. Do whatever you want, or turn off the camera, and then you won't be able to see. I would not recommend doing that.